Hello, Prep 1. Today we will complete Lesson 2, Unit 1, Chemical Compounds. What is meant by valency? Valency is number of electrons which atoms gain, lose, or even share during the chemical reaction. Examples: sodium Na11 is monovalent. Why? Because it contains one electron in its outermost energy level, so it can use it during the chemical reaction. So sodium is monovalent metal. Chlorine Cl17 is monovalent because it contains 7 electrons in its outermost energy level, so it gains one electron or share one electron during the chemical reaction. So chlorine is non-metal monovalent. Some examples of valences for metals and non-metals. We must keep this table in our mind, as some metals monovalent as lithium, potassium, sodium, silver, and copper. Some non-metals monovalent as hydrogen, chlorine, fluorine, bromine, and iodine. Some metals divalent as calcium, magnesium, iron, lead, copper, and mercury, and non-metal divalent as sulfur and oxygen. Trivalent metals as aluminium, gold, and iron. Some trivalent nonmetals as nitrogen and phosphorus. Tetravalent nonmetal as sulfur and carbon. Pentavalent nonmetal as nitrogen and phosphorus. Hexavalent as nonmetal sulfur. It's a very important note here. Valency of noble gases is 0. And there is a question, give reason here. Because their outermost energy level is completely filled with 8 electrons and don't share in chemical reactions. What is meant by atomic group? It is a set of different atoms. Atomic group, set of different atoms which are joined together and behave like one atom during the chemical reaction, having its own valency. Some example of valencies of atomic groups, and we must keep this table also. The valency of monovalent atomic group as hydroxide group, negative hydroxide group, negative bicarbonate group, negative nitrate group NO3, negative nitrite group NO2, and the positive ammonium atomic group NH4 positive 1. Divalent atomic group as carbonate group CO3 negative 2, sulfate group SO4 negative 2, and trivalent atomic group as phosphate group BO4 negative 3. What is meant by chemical formula? Chemical formula represents the number and the type of the atom in a molecule. Chemical formula represents number and type of atoms in a molecule. How can we write a chemical formula in a compound? We have some steps, we must do them to make a chemical formula. The first step, we must write the name of the compound in words. We must write the name of compounds in words. Number 2, write the symbol of each element or atomic group. Write the symbol or each element of atomic group. Number 3, write the valency down to each symbol or atomic group. Number 4, exchange their valences and simplify as we can. We don't have to write number 1 under the symbol. In case of atomic group, if the number is not 1, we must put the atomic group between brackets and write the number of the valency, write down it. We have some example to make a chemical formula to the compound aluminium oxide. The first step, write the symbol of aluminium, Al, oxide, oxygen, O. The second step, write the valency of each element under it. The valency of aluminium, as we know, is trivalent, and the valency of oxygen divalent. Then the last step, we make exchange the valences and write Al 2O3. So the chemical formula of aluminum oxide will be Al2O3. Types of compounds. We have 4 types of compounds around us: acids, bases or alkalis, oxides, and salts. The first one we will talk about acids and base. We have a comparison between them. What is meant by acids? They are substances or materials which dissociate or dissolve in water, producing positive hydrogen ion. They have sour taste, change color of litmus paper into red. Give reason: because or due to presence of positive hydrogen ion. Its chemical formula of all mineral acids begin with positive hydrogen ion. Positive hydrogen ion. So we can know this acid when its chemical formula starts with positive hydrogen ion. So it's called an acid. Examples of acids: sulfuric acid, H2SO4, nitric acid, HNO3. So, what is meant by acids? They are substances which dissociate or dissolve in water and give positive hydrogen ion. Some properties of acids: they have sour taste, change litmus paper into red due to presence of hydrogen ion, positive hydrogen ion. Its chemical formula starts with positive hydrogen ion, and some examples: sulfuric acid and nitric acid. What about bases? Bases are also substances which dissolve in water or dissociate in water, producing negative hydroxide ion. Negative hydroxide ion. Some properties of bases: they have bitter or slippery taste, change litmus paper into blue due to presence of negative hydroxide atom or ion, due to presence of negative hydroxide ion. And its chemical formula ends with negative hydroxide ion. So acids, all chemical formula start with positive hydrogen ion, and bases ends with negative hydroxide ion. Some examples of bases as sodium hydroxide, NaOH, calcium hydroxide. Sodium hydroxide called caustic soda, and calcium hydroxide is lime water. Oxides. Number 3, oxides. Oxides are compounds resulted from combination between oxygen and element. And there are 2 types of oxides: metal oxides and non-metal oxide. Metal oxide results from combination between metal and oxygen. Metal oxides formed from combination between metal and oxygen. Some examples of metal oxides: sodium oxide, Na2O, calcium oxide CaO, aluminium oxide Al2O3. Non-metal oxides resulted from combination between non-metal and oxygen. Some examples: carbon dioxide CO2 and sulfuric oxide SO3. Number 4, salts. They are compounds resulted from combination between positive ion or positive atomic group. So, what is meant by salts? They are compounds. Salts, they are compounds resulted from combination between positive ion or positive atomic group with negative ion or negative atomic group, except negative ionic group or negative non-metal except oxygen. Why except oxygen? Because when positive ion combine with oxygen, it will form oxide. But we talk about salts. So, salts are compounds resulted from combination between positive ion or positive atomic group with negative ionic group or negative non-metal except oxygen. Some properties of salts: it exists in Earth's crust. They exist in Earth's crust dissolved in water. They are different in taste, color, smell, and solubility in water. There are two types of salts: dissolvable or insoluble salts. Some mineral salts are dissolved or soluble in water as sodium chloride NaCl, potassium sulfate K2SO4, calcium nitrate Na2S, magnesium carbonate MgCO3. Some salts are not or undissolved or insoluble in water as silver chloride AgCl, lead iodide PbI2, lead sulfate BbSO4. This table shows types of salts, or how salts are formed. Some salts formed from combination between positive ion and the negative ion, as sodium chloride. Sodium is positive ion and chloride negative ion. Lead bromide, lead positive, bromide negative, Br2. Positive ion with negative atomic group, positive ion as sodium, negative atomic group as nitrate group. Magnesium carbonate Mg, positive ion, and carbonate negative atomic group. Some salts result from negative atomic group with negative ion as aluminium chloride NH4, positive atomic group with Cl negative non-metal. Ammonium bromide NH4 Br, ammonium positive atomic group with negative Br. Some salts results from negative atomic group with positive atomic group as NH4 by 2 CO3. We will have a revision in this lesson. The first question, give reason. When he asks me give reasons, the valency of noble gases is 0. Why the valency of noble gases is 0? As we said, because or due to completeness of their outermost energy level with 8 electrons. Number 2, give reason. Acids turn color of litmus paper from blue to red due to presence of positive hydrogen ion. Give reason. Bases turn color of litmus paper from red to blue due to presence of negative hydroxide ion. Give reason. An oxygen atom joins with two atoms of sodium when composing one molecule of sodium oxide because oxygen has a valency divalent. Because oxygen has valency divalent. Another question, and a very important question here, write the chemical formula for each compound. Aluminium carbonate. As we said, the first step, we must write the symbol of aluminium, Al, carbonate, atomic group CO3. Then we write the valency of each element under it. Aluminium, it's a valency 3. Carbonate, it's a valency 2. Then we make exchange or cross. Al will take 2. CO3 we will take 3. So the chemical formula here will be Al2CO3 by 3. As we said, when the atomic group have valency more than 1, we must put them between brackets. As we see, carbonate group will take 3 from aluminium, so we will make it between brackets. Calcium chloride, the first step, calcium, Ca, oxide, O, the valency of calcium 2, the valency of oxygen 2. As we said, we must make simplify as we can. 2 divisible to 1, 2 divisible to 1, so CaO. The chemical formula of calcium oxide, CaO. Complete. Space and space are examples of acids, while space and space are examples of bases. Examples of acids: sulfuric acid, hydrochloric acid. Examples of acids: example of bases: sodium hydroxide, potassium hydroxide. Number 2, on dissolving in water, acids give positive hydrogen ion, while bases give negative hydroxide ion. We can use space to distinguish between acids and bases. As we said, we can use litmus paper to differentiate between acids and bases. Some metallic elements have more than one valency, such as copper and iron. Some non-metallic elements have more than valency, such as sulfur and phosphorus. Identify the type of the following compounds: KOH, NaCl, MgO, and H2SO4. As we said, when the chemical formula ends with OH, negative hydroxide group, so it must be base. So the type of KOH, base or alkali. NaCl doesn't start with positive hydrogen or doesn't end with negative hydroxide, so it will be salt. MgO has oxygen, so it will be oxide. We have 2 types of oxide, metals and non-metals. Mg, magnesium, as we know, is a metal, so it's metal oxide. H2SO4 starts with positive hydrogen ion, so it must be acid. Another question here, write the chemical formula for magnesium oxide, MgO, iron oxide, FeO, sulfuric acid, H2SO4, hydrochloric acid, HCl. Okay, thank you.